Hello students, welcome to the class of digital electronics. Today we will start the topic signed number. So if we categorize the in broad way the whole number system, there are two types. First is the signed number and another one is the unsigned number. First one is the signed number, second is the unsigned number. So unsigned number. So in unsigned number only we can represent the positive number. Only we can represent the positive number. But in the signed number, we can represent the positive as well as negative number. So these two types are the uh, types of the number system. Okay, so signed number and unsigned number. So further, signed binary number, we are again categorized into three parts. First is the signed magnitude representation. Second is the ones complement representation, and third is the twos complement representation. So first is the signed magnitude representation. This signed magnitude representation, that it is a type of the signed representation. Clear? So now you see this signed magnitude representation, this coming under the signed number. It is one of the type of the signed number where we can represent the positive as well as negative number. So in signed magnitude representation, let's say if we have the n bit, if we have, let's say, n bit, so this MSB, this one is MSB, this MSB is reserved for the sign bit. Okay, so let's say this MSB is 0, then number is then number is positive. Correct? First point. And second point is, if MSB is 1, then number is negative. So this MSB is reserved only for the sign, and rest n minus 1 bit is responsible for its magnitude. Correct? These are the magnitude bit, and this one is the sign bit. So range is as n minus 1 number of bits are used to represent the magnitude. So range is minus 2 raised to power n minus 1 minus 1 to plus 2 raised to power n minus 1 minus 7. So this is the range. So negative number to this positive number. So let's say, for example, plus 6. So how do we represent the plus 6 in sign magnitude representation? This MSB is reserved for the sign. So this number is positive. Okay, and this 3 bit, this is represent this 3 bit are representing the magnitude. So this is the magnitude that we have, that is 6. Okay, so finally that plus 6 is the number. Minus 6, this MSB is 1, so that means this number is negative, and rest of the bit are used to represent the magnitude. So this magnitude, this is the 6, and this one is minus sign is there. So this is minus 6. Clear? So in sign magnitude representation, positive number is represented by simply MSB is 0. Negative number is represented by simply MSB is 1. See, now further, let's say in 4 bits, so sign magnitude representation, this is a 4 bit, so this MSB is reserved for the sign. So this is a plus 0, this one is plus 1, this is plus 2, plus 3, plus 4, plus 5, plus 6, and plus 7. This is plus 7 because this MSB is 0, so that's why it is a positive, and this rest remaining bit are used to represent the magnitude. So that is a 7. So this is a plus 7. So in continuation 0 1 1 1, that is 1 0 0. So in 4 bit, how many possible combinations are there? 16 possible combinations are there. So 1 triple 0. So 1 triple 0 is minus 0 because this is MSB. So MSB is 1, means understood it is the negative number, and rest remaining bit is used for the magnitude. So it's a minus 0. Same here is this one is minus 1, this one is minus 2, minus 3, minus 4, minus 5, minus 6 and minus 7. So in 4 bit we can represent from this minus 7 to plus 7. Clear? So range is, again I am writing, range is minus 2 raised to power n minus 7 minus 1 to plus 2 raised to power n minus 7 to minus 1. Say n is equal to 4. So put here n is equal to 4, minus 2 to the power n minus 1 means 4 minus 1, that is 3 minus 1 to 2 raised to power 3 minus 1. So 2 raised to power 3 is 8 minus 1 is 7. So minus 7 to plus 7. So as we have already seen, in n is equal to 4, so number of bit, if suppose 4, so we can represent from minus 7 to here minus 7 to plus 7. Okay, the sign magnitude representation. If suppose n is equal to 8, so we can represent from minus 27 to plus 27. Okay, so now the next, in continuation of the sign magnitude representation, the disadvantage of sign magnitude representation. So first disadvantage is, as we have seen here in the previous slide, so there are two representation of 0. One representation is this one, another representation is this one. So the disadvantage is there are two representation of 0. All 0 and MSB is 1 and remaining bits are 0. Clear? So two representation of 0 is there. So this first point is clear. Now second point is extension of number of bit is difficult. So what does it mean? Extension of number of bit means, let's say if we have here, just I am writing one example. Let's say we have number 0101. So this number is plus 5. This number is plus 5 because this is plus positive and remaining bits are magnitude. So that is plus 5. So correct. If suppose minus 5, minus 5 is there. So minus 5 is 1101. So this is minus 5. Correct. So extension of number of bit is difficult means if we extend the number of bit, here number of bit is 4. So if suppose we are extending the number of bit, say number of bit, that is total number of bit is 5. So 11101. Okay. So how do we extend the number of bit? By simply copy the MSB bit. By simply the copy the MSB bit. That is the meaning of the extension of a number of bit. So if we extend the number of bit, so this number is minus 13. This number is minus 13. So extension of number of bit is difficult. So the same value we cannot retain. So this value is minus 5. So this value should be minus 5 if we are extended the number of bit. Okay, so that's why the extension of a number of bit is difficult in sign magnitude representation. During third point is during addition, if carry occur, then we have to add the carry into the LSB position to get the final answer. Correct. So in the previous lecture, this already that we have seen in the ones complement also, if carry occur, then add the carry into the LSB position. Okay, to get the final answer. So same here also in the sign magnitude representation, during addition, if carry occur, then again we have to add the carry into the LSB position. So these three are the disadvantages of sign magnitude representation. Next is second one is ones complement representation. So in ones complement representation, positive number is represented as the same way as we have represented in sign magnitude representation. So positive number, again I am repeating, positive number is represented in one's complement form, in one's complement representation. Again I am repeating, in one's complement representation, positive number is represented as the same way as we have represented in the sign magnitude representation. Clear? But the negative number is represented by taking the ones complement of the corresponding positive number. Clear? So the range is also the same as we have in the sign magnitude representation. Clear? So let's say for example this one. This is plus 6. This one is plus 6. 0, 1, 1, 0. Okay. So according to the range, see this point. According to the range in 4-bit, what is the range? Minus 7 to plus 7. So minus 7 to plus 7 only we can represent in the ones complement representation. Now the question is, how do we represent the plus 7? How do we represent the minus 7? Correct. So the point is, let's say for example, this plus 6 is there. So this MSB is 0. MSB is 0 and rest remaining bits are for magnitude. So this is the plus 6. Okay. So minus 6, how do we represent the minus 6? How do we represent the minus 6? Negative number is represented, is represented by taking the complement of the ones complement of the corresponding positive number. So ones complement of this one is 1001. So this is minus 6. Clear? Let's say for example again, let's say for example minus 7. So how do we represent the minus 7? First we have to write the plus 7. Okay, so plus 7 is 0, 1, 1, 1. This is my plus 7. This is my plus 7. Okay, so how do we represent the minus 7? Simply we have to take the ones complement of this one. Okay, so ones complement is 0, 0, 0, 1. Okay, so this is my minus 7. This point is clear. So negative number is represented by taking the ones complement of the corresponding positive number. Clear? So in ones complement, the benefit is extension of number of bit is easy. Simply copy the MSB bit as we have seen in the sign magnitude representation where the extension of a number of bit is difficult. But in one's complement representation, the extension of a number of bit is easy. So let's see, 0, 1, 1, 0 is plus 6. So if we copy the MSB, then 0, 0, 1, 1, 0, again it's a minus, is again is a plus 6. 0, 0, 1, 1, 0, again is a plus 6. So if we are extending the number of bit by simply copy the MSB, we are retaining the same value. Plus 6 is there. This is also plus 6 is there. Clear? Now in negative number side, so minus 6 is taking the ones complement of the corresponding positive number. Okay, so this is the ones complement of this number. So that is a minus 6. So if suppose we want to extend the number of bit, so by simply the copy the MSB. Okay, so 1, 1, 0, 0, 1. This is again minus 6. Okay, in 6 bit again this is minus 6. So if we copy the MSB, let's say this one, again this is minus 6. Okay, so how do we say this is minus 6? Correct. So take the ones complement of this one. Take the ones complement of this. So ones complement is, ones complement, let's say ones complement is 0, 1, 1, 0, 0. Correct. So 0, 0, 1, 1, 0 is, that is plus 6 is there. So this number is minus 6. So here in ones complement representation, negative number is represented by taking the ones complement of the corresponding positive number. and positive number is represented as the same way as we have represented in the sign magnitude representation. Correct? So in the sign magnitude representation, positive number is represented by simply MSB is 0 and remaining bit is for magnitude. So now for example, one in the ones complement, say this is plus 5, this is minus 4. So we need to subtract this 4, okay, from this 5. So in ones complement, so plus 5, we have to write this plus 5, this is plus 5. Okay, how do we know this plus 5? Because this is positive, because MSB is 0 and remaining bit is magnitude. Correct? Now how do we represent this minus 4? This minus 4, this minus 4. Okay, so first we have to write the plus 4. This is my plus 4. Okay, take the ones complement of this one. So ones complement of this is 1 1 0 1. This is the ones complement of this number. So this is my minus 4. Correct? This is my plus 5. So we have to add this 0 1 0 1 0 1 0 1 and 1 0 1 1. So 1 0 1 1. This is minus 4. Now add these two, 1 1 0 with carry 1, 1 1 0 with carry 1, 1 1 0 with carry 1, 1 1 0 with carry 1. So in one's complement, again we have to add the 1 in the LSB position. So this finally 1 0 0 0. So this is finally plus 1. Okay. Why plus 1? Because this MSB is 0 and remaining bit is for magnitude. So this is plus 1. Clear? So now point is two arithmetic operation is required. Okay, while subtraction using ones complement. So there is a one disadvantage is there. Okay, so here now see, first disadvantage is two representation of 0 in the ones complement. There are two representation of 0. Clear? And during addition, if carry occur, then add plus 1 into the result to get the final answer. Clear? So these two are the disadvantage of ones complement form. So two representation of 0, which one two representation? All 0 and all 1. These two are the representation, both are the representation of 0. Clear? So advantage is extension of a number of bit is easy by simply copy the MS repeat. This already that we have seen here. Here, this one. So extension of a number of bit is easy. Correct? This is the advantage. Now the third is two's complement representation. Two's complement representation. So the range, first of all, this range. Okay, range. This range already that we have seen in the sign magnitude representation. This already that we have seen in the ones complement representation, and in two's complement representation. Now you see the difference. Positive number is represented as the same way as we have in ones complement and sign magnitude representation. Correct? So the range is also the same. Range is also the same. I am repeating one more time. Positive number is represented as in the two's complement form. Positive number is represented as the same way as we have represented in ones complement form or in sign magnitude form. Correct? But the negative number, the negative number is represented by taking the two's complement of the corresponding positive number. Clear? Now you see here in sign magnitude, plus 0 is, this is the plus 0 because this sign is positive and remaining all this is for 0. Okay, what about the minus 0? Minus 0 is, this is the minus 0. Why minus 0? Because this MSB is negative, this is representing the negative, and this one is 0. So that's why it's a minus 0. In one's complement, positive number is represented as the same way as we have represented in the sign magnitude. Okay, so this is the plus 0. And negative 0, how do we represent negative 0? Take the ones complement of the corresponding positive number. So if I am taking the ones complement of this positive number, that is my minus 0. Clear? In 2's complement, positive 0, this is the positive 0, this is the plus sign is there, and this one is the 0, all 0. So positive number is represented as the same way in the as we have represented in the ones complement or in the sign magnitude. But the negative number, in 2's complement form is represented by taking the 2's complement of the corresponding positive number. Correct? So as here there is no representation of negative 0. There is no representation of negative 0. Correct? Only single representation of 0 is there. So that is the plus point of 2's complement. Okay, and that's why now you see here the negative number minus 2 raised to power n minus 1, because only single representation of 0 is there. So there is no negative 0 in the 2's complement. That's why just you see the difference in sign magnitude in 1's complement, and now here 2's complement. Here 2's complement minus 2 raised to power n minus 1. That's it. Clear? So in 2's complement, the plus 6 is, this is the plus 6. How do we know this plus 6 is there? This is positive sign, and this remaining is, that is magnitude. So this is a plus 6. So how do we represent the minus 6? Take the 2's complement of the corresponding positive number. Okay, so 2's complement of this plus 6 is 0, 1, 1, 0. So this is my minus 6. This is my minus 6. Correct? So again, one more example is a number is represented in 2's complement form is this one. This number is in the 2's complement form. What is the decimal equivalent? Okay. So now first point is the MSB is 1. So it is understood that this number is negative. First point is, again I am repeating, first point is because it is in the 2's complement form and MSB is 1, so it is understood that this number is negative. So what is the decimal value of this 2's complement form? So this is not the readable form. This is not the readable form. This is in the 2's complement form. So better to take the 2's complement of this number. So if we are taking the 2's complement of this one number, 2's complement is 1, 1, 1, 0. So 1, 1, 1, 0 is plus 7 because MSB is 0. Okay, and this one is 7. So this is plus 7. So if this is plus 7, then this one is minus 7, and this one is minus 7. So then its decimal equivalent value is minus 7. Okay, now in 4 bit, in 2's complement, 4 bit is, that is 0, 1, 2, 3 up to 7, and minus 1, 2 up to minus 8. So now you can see here there is only single representation of 0 is there. Only single representation of 0 is there. Correct? So now you see here F in 2's complement form is given. Okay. Now its decimal equivalent is, what is the decimal equivalent of this F? This F in 2's complement form. So here now you see this F, this 1, 1, 1. Okay, 1, 1, 1, again 1, 1, 1, and 1, 1, 1, 1. Okay, because this MSB is 1, so that is understood that this number is negative. This whole number is negative. Clear? Correct? So how do we find the decimal equivalent of this number? By simply taking the 2's complement of this, 2's complement, and 2's complement of this number is 1, 0, 0, 0, 0, 0, 0, okay, 0, 0, 0, 0, and 0, 0, 0, 0. So this is what this is 1, this is 0, this one is 0, and this one is 0. Okay, so finally this is 1. So if this number is 1, so this number is minus 1. Clear? So negative number is represented by taking the 2's complement of the corresponding positive number. So now advantage of 2's complement, as we have already seen, there is single representation of 0 is there. Single representation, what is the representation is all 0. All 0 is only the representation of 0. Second is extension of a number of bit is easy. Extension of a number of bit is easy. So let's say uh, 0 1 1 1. So this is what? This is a plus 7. Okay, so if we are just simply copy the MSB, then this is again plus 7 is there. If let's say again, if I am copying the MSB, then this is again this plus 7 is there. Clear? Correct? So let's say minus 5. So how do we represent the minus 5? First we have to find the plus 5 value. So plus 5 is, this is plus 5. Plus 5 is 0 1 0 1. Now minus 5 is, take the 2's complement of this one. This is my plus 5. Now take the 2's complement is 1 1 0 1. Correct? So this is the 2's complement of this one. So this is my, this number is my minus 5. Okay, so 1 0 1 1 is minus 5. Again, if suppose if I want to extend the number of bit 1 1 0 1 1, this is again minus 5. 1 1 1 0 1 1, this is again minus 5. So how do you know this is minus 5? Because MSB is 1. Okay, and simply by taking the 2's complement of this number, that is my, that is my plus 5. Clear? So just you take the 2's complement of this. So 2's complement of this one is 1 0 1 0 0 0. This is the 2's complement. So this one is plus 5. So if this one is plus 5, then this is minus 5. Clear? Now the third point is, only one arithmetic operation is required while subtraction using 2's complement when carry occur. So if carry occur, we have to simply discard the carry. Okay, and we are getting the final answer. So only one arithmetic operation is required while subtraction. Okay, while subtraction using 2's complement. Clear? So these three advantages is there in the 2's complement. So in the next lecture we will solve few good example based on the signed number, signed magnitude representation, one's complement representation, and two's complement representation. Clear? Thank you very much.